Hello and welcome to another episode of Deep Learning. And today we are going to discuss about image classification using convolutional neural network. So it is going to be a discussion on the basics of how to use convolutional network, different types of concept relevant to this, and later we'll also see some code and how to implement it on a dataset. So today we are going to use CIFR 10 dataset. It is free and you can utilize in your project. So it is a collection of around 65,000 images of different objects like frog, cat, deer, airplane, truck, etc. So the major goal is to use the convolutional neural network for classifying these images. So let's start. But before starting the coding about this project, and we want to clarify some background relevant to deep learning. You already watched a video in this channel about the deep learning bootcamp, so you can also check this for elementary understanding. So this is a little bit advanced level, so if you have already watched the first video, then it will be helpful for you. So you will get the link of this first video somewhere in the description below. So let's begin. Let's move to our first slide. So what is convolutional neural network? So in short, we use the abbreviation CNN. So CNNs are a class of deep learning models specifically designed for processing and analyzing visual data such as images and videos. So visual data are different from numerical data, right? And the process that you use for numerical data are not suitable for non-linear data such as image and text. So these particular neural network, convolutional neural network or CNN, are widely used in computer visions such as image recognition or image classification, object detection, and image segmentation, and many more. So dear friend, we can use this convolutional network for classifying the images. The key idea behind CNN is automatically learn hierarchical representation of the input data by using convolutional layers and pooling layer. Now, what is convolutional layer? What is pooling layer? We'll discuss these one by one. And these layers, in deep learning, there is one input layer, there are several hidden layer, and then you get the output layer. So here inside the hidden layer, you have convolutional layer, you have pooling layer, and these layers allow the network to efficiently detect local patterns and features in the input, and also reduce the computational complexity and the number of parameter in the model. So in the next slide, we'll see a simple diagram for understanding these convolutional layers and pooling layers. So let's move to our next slide. And the next slide, we see the fundamental component of the convolutional neural network consist of some input layer, convolutional layers, and some pooling layers. You have some fully connected layers, and then the output layer you can see in this particular diagram. So here we see that the convolutional layers has a very significant role in this whole process. Convolutional layers apply some filters, and these filter to the input and to extract specific feature. Why they use this filter? Because this filter can extract some specific features from the images, and these filters slides or layers over the entire input images and computes the dot product of different locations. So where these kind of pixels are there that are similar, so it is an operation results of feature mapping. This is called feature mapping, finding out the features from the image, and it highlights the presence of different patterns and features in the input data. So you suppose you are inputting a lot of cats images, so it will find the feature of cats like cat's eye in all the cats related features, and it will find this pattern. And these filters are learning during the training process. When you are inputting a lot of training data, it is actually learning from this training data and allowing the network to automatically detect relevant patterns. So it finds some relevant patterns from the training data. So everything is going behind the scene. You cannot see this when you are running this code, but you need the concept that what is the function of convolutional layers. Then you have some activation function. So activation function is a very important concept in deep learning. After each convolutional operation, an active function is applied element wise to introduce the non-linearity in the network. So some commonly used, there are different type of activation functions are available. We'll discuss different type of activation function in a later slide, but here you just try to understand that the most popular activation function that is used is called rectified linear unit, or ReLU, which is a set of negative value to 0, which set the negative values to 0 and positive value unchanged. So after doing this filter, we get only positive values, all the negative values are removed, and the non-linearity enables the networks to learn complex relationship and make the model more expressive. So next is the pooling layer. So pooling layers perform downsampling on the feature map and selecting a representative value from a small region like 2 cross 2 as an input, and the most common pooling operation is max pooling. So max pooling is a ready to use function for adding some pooling layers which takes the maximum value of a region. So when it is selecting a small layer, small 2 cross 2 layer from the picture, it is taking the max value, and pooling reduce the spatial dimensions and makes the network more computational efficiently and robust to transition in the input. Now the next layer is fully connected. You can see the fully connected layers, and it is just before the output layer. So after several convolutional and pooling layers, you don't know how many convolutional layers behind that it is working and how many pooling layers are the result, resulting the feature map. So feature map and flattened into 1D vectors. So 1D vector is a type of data. The vector is then passes through fully connected layers and which perform traditional neural network operation, and these layers combine the learned feature. So all the features that are learned from the previous layers make some sort of decision. This is helping them for making decision, and the output layer shows this decision. Here another concept is called the loss function. The loss function is used to measure the differences between the predictive output and the target level during the training. So from classification tasks, the commonly used loss functions include softmax, and we'll use softmax in the example you will see, and this include softmax cross entropy for multi-class classification and binary cross entropy for binary classification. The learning process of a convolutional neural network involves forward propagations, where the input data passes through layers to generate predictions, and backward propagation. What is backward propagation? In backward propagation, the model learn from the errors and update the weight of the filters to minimize the loss function. So the convolutional neural networks have demonstrate exceptional performance in wide range of computer vision related tasks, and it is really significant and contributing a lot in the advancement of this computer vision related field. And using that you can do object detection and image generation and etc. So we understood some fundamental component of convolutional neural network. Let's try to understand a package right now, because different type of packages are machine learning packages or libraries are useful for doing these projects. So the most useful machine learning library, you can guess, it is TensorFlow. So what is TensorFlow? Let's try to understand it from the next slide. So TensorFlow is an open source machine learning library developed by Google Brain team, and it is one of the most popular and widely used deep learning framework, and that allows developers and researchers to build and train machine learning models efficiently. So dear friend, TensorFlow provides a flexible and comprehensive ecosystem for various tasks, including numerical computation, data flow graphs, automatic differentiations of gradient based optimization, etc. So let's see what are the features of TensorFlow. When you learn more about features of TensorFlow, you can utilize this tool in a better way. So the next slide shows the features of TensorFlow. The major features are symbolic computation. TensorFlow use symbolic computation graphs where data flows through nodes represented by tensors, and these graphs enable parallel and distributed processing, making TensorFlow suitable for high performance computation. Now it has a very significant part in deep learning. TensorFlow is particularly well suited for building and training deep learning models, and that include artificial neural network, convolutional neural network, recurrent neural network, so and many more. And it has flexibility offer for high level API like Keras. We'll use Keras in the example project, and it is easier for modeling and abstractions, as well as low level APIs are useful for fine grinding the control over the model architectures and training process. It has the portability. What portability here, by portability we means that TensorFlow support various hardware platform such as CPUs, GPUs and TPU means tensor processing units, make it versatile, and the researcher and developers are capable to run it efficiently on different devices. It has the scalability. It supports distribution computation, allowing user to distribute model training across multiple devices and machines, and it is well suited for large scale machine learning tasks. Then you get a large community of ecosystem around the world who are contributing on the forums and support group, and there are numerous pre-trained models available, tools are available, so you get plenty of resources for building your next machine learning model or deep learning model. You can easily integrate the TensorFlow, and the integration is seamless. You can add various other libraries that support TensorFlow and that leverage the programming, and you can make your code more advanced and efficient. So the deployment is easy. TensorFlow can be exported in various format, including mobile device and web, making it easy to deploy machine learning model in a wide variety of real world applications. So TensorFlow has been used extensively in a wide range of applications such as computer vision, natural language processing, speech recognition, recommendation system, and image recognition as well. So it has the popularity that it is one of the strongest machine learning community, and TensorFlow has played a significant role in the advancement of machine learning and has contributed by various developer and researchers. So we understood the key features of TensorFlow. Let's move to the next tool that is important for this project is this Jupyter Notebook. I think you are already familiar with Jupyter Notebook. Just for understanding what is Jupyter Notebook, it is an open source web-based application, and it allows user to create and share documents that contain live code, equations, visualization, and narrative text. And Jupyter Notebook is open source. You can easily download it, and you can share live code, equation, and visualization. Originally this software was known as IPython Notebook, but later it is changed to Jupyter Notebook, and it support Python, R, Julia, and different type of coding, and the name Jupyter is a combination of the popular programming language Julia, Python, and R. Okay, so we understood Jupyter Notebook. Let's see its major feature. Number one feature is interactive computing. Jupyter Notebook provides an interactive computing environment, enabling user to run code cell individually, and you can see the result immediately. So in the first cell you are typing the code, and the next cell you can see the output just by clicking the run button. You can run a particular cell. So code execution is very easy. User can write and execute code say in separate code cells, and the output such as print statement and visualization is easily displayed on the same page. It has the reshaped support, so you can use markdown cell for giving a description about the tasks you have done. So the commenting process is very simple. You can add various type of comments that are relevant to your code. Data visualization is easy. Jupyter Notebook is integrated to different type of data visualization library like matplotlib, seaborn and plotly, and that's enable you to see the output in the form of a graph on the same page of this web application. So we understood the various feature of Jupyter Notebook from this slide. Next we see that what are the additional features of this notebook. We can do data exploration. The Jupyter Notebook facilitate data exploration and analysis by allowing the user to interact with data platforms, calculation and visual results in real time, and they can see the visual results in real time. Integration with data science library, you can add different type of data science library using some import command, and you can use NumPy, scikit-learn, TensorFlow. So Jupyter Notebook is friendly with various types of data science and machine learning workflow, and that's why the seamless integration make it more popular among the developer and researcher. It has collaboration and sharing features, so notebook can be easily shared with a group of developer and researcher, and user can share notebook via email and GitHub, and this is why it is so popular. It also has the kernel support. Different type of kernel language are supported by Jupyter Notebook. Each notebook runs a specific kernel that interprets and execute code in the respective language. For education and teaching, it is very helpful because it is free, open source. Jupyter Notebook has gained widespread of popularity among the data scientists, researcher, educators, students and developers, and because of its versatility, interactivity and visualization capability, documentation capability, etc. So it is an essential tool. You can download it free from the website. You can search Jupyter Notebook download in Google. You can find the website link, and if you install Anaconda as a Python library, you get this particular tool. So I will use Anaconda for this. So let's move to Jupyter Notebook installation and this process. Dear friend, when you install Anaconda, you get a link here, Jupyter Notebook. Just clicking the launch button, you can launch the Jupyter Notebook. It will open a page like this, localhost/3, and this URL you can see the folder of your PC. Here is a data set of cats and dog that actually coming from the dataset that we are using. So you don't need to download the images because the code will show import this dataset to your Jupyter Notebook file. So here, by clicking the new button, new Python, you can start one Jupyter Notebook file. Then here you can rename or save this file to a particular location, and if you want to start the Jupyter Notebook to a particular location, then just open that location in command prompt and write Jupyter Notebook. You will see that the Jupyter Notebook will open this file in this particular location. So let's move to our next slide for understanding the relevant concept first, because without understanding the relevant concept of how to do the coding, it is not easy to start coding. So here you can see, if you want to open your Jupyter Notebook in E drive, then just enter into E drive and type Jupyter Notebook, and you can start the coding. Okay, please check the notebook. Jupyter Notebook spelling must be correct. For that, here if you make some sort of mistake in typing that, you will see an error, and when you are typing it correctly, it will open the code here. So we have opened this particular folder where the dataset is located. but we will not use these images from the folder. Instead, we'll run this code on Google Colab, because if your computer's processing capacity is slow, it will take a lot of time for training the model using the training dataset. So if you use the Google Colab, it will work fast, because Google Colab process the code very fast compared to local Jupyter Notebook file. So I'm showing you the process how you can create a Jupyter Notebook file on your folder, less on your local PC. And let's move to our next slide for understanding the concepts first. So, dear friend, we understood different features of Jupyter Notebook. Let's move to our next slide. What is activation function? It's a very important topic. So, activation function is basically a feature of your convolutional neural network. So, an activation function is known as a transfer function. It is critical component in the artificial neural network and deep learning model. It introduces non-linearity in the network and allows to learn complex patterns and make decisions based on the input data. Activation functions played a crucial role in determining whether a neural network be activated or not based on the weighted sum of the input. In this context of neural network, the activation function is applied to input such as neuron and the layer, and output of activation functions become the input of the next layer. So one particular layer is taking the data and it is giving some output, and that output become the input for the next layer, and this is how it is propagating in the forward direction. So by introducing non-linearity, the model can learn complex and non-linear relationship in the data and make it capable for handling more interactive pattern and achieve higher level of performance. So dear friend, you can see different type of activation functions are available. We'll use particularly the ReLU function. ReLU function is important because these functions return the input as it is positive and 0, otherwise it is ignoring the value. The function is fx is equal to max of 0 comma x. So ReLU become the most commonly used active function in the deep learning due to its simplicity and its ability to mitigate the vanishing gradient problem. Okay, so what is vanishing gradient problem? We have discussed in the previous video number 1. There are other activation function like the exponential linear unit, and we will not use the others. We will use only rectified linear unit. You can search what is the sigmoid function. So sigmoid function is basically maps the input to a range between 0 to 1, and its function is written as fx is equal to 1 by 1 minus exponential of minus x. And this sigmoid function has wide use in the past, but its vanishing gradient problem hinders its application in the deeper network, so that's why it is not so popular. Let's move to some questions and answers. We'll try to understand the problem first using some question and answer. What type of dataset we are using here? We are using CIFR 10 dataset, and CIFR 10 dataset contain around 65,000 images, so small images of various objects, and you can use this for your analysis. So normalizing the pixel value to a range of 0 to 1, and it is essential to our first question is, what is the purpose of normalizing the pixel value of the images from this dataset? So when you do normalizing, the normalizing is of the pixel value, ensure that the features have similar scales, and it helps faster conversions convergence into faster conversion during training and prevent issues such as exploding gradient. By dividing each pixel value by 255, we transfer the image data to a continuous range and which is suitable for training neural network efficiently. Then our next question is, what is flattened layer used in the first neural network? The flattened layer is used to convert dimensional input image 32 by 32 into 3. So it is a one-dimensional vector before processing the fully connected layers, and the flatten process is necessary because the fully connected layers required 1D input. The flattened layer preserves the relationship with each channel, and while creating the flat vector suitable for further processing. So let's start the coding and see how it is occurring. So first of all, what you need? First of all, you need to write some code that is going to add the TensorFlow in your particular data. TensorFlow in your particular Jupyter notebook file. So let's see. Dear friend, if you are using your local Jupyter notebook, then install the TensorFlow using the command pip install TensorFlow. So when you write this command using the command prompt, it will take some time for installing TensorFlow locally. It is around 275 megabyte file, so it will take some time for installation process. During this time, we need to wait for this. So I'm taking a pause here, and here you can see the TensorFlow is installed. Maybe it will show some sort of little error if there is any permission related things there. So once you have installed TensorFlow, then you can write this code from tensorflow.keras, and then you are going to import these relevant packages. So this code start by importing the necessary libraries that include TensorFlow and Keras API, and we'll also need to add some NumPy for numerical operation, and for visualization we'll use matplotlib. These are some important packages. So you can see we are writing in TensorFlow Keras model import sequential and TensorFlow Keras model import the conv d and then other. So here we want to do this coding on the Google Colab for fast processing. So dear friend, we have changed the last line. So here we move this particular code to a Google Colab file. So we are using this code, this import section, and then importing the dataset. If this code is not visible, I'm showing you another way. So dear friend, here you can see the code more visible. We are importing TensorFlow, Keras, then matplotlib and NumPy. You can call NumPy earlier also. Then when you write this particular code, it will download the data from this URL and it will add to your Google Colab file. It will take some time, like 7 seconds for running this code, and then you can also see the shape of this data here. So basically what is going on here, let us try to understand it theoretically. So first the code started with importing the necessary libraries including TensorFlow, Keras API and NumPy, and also matplotlib is also added to this, and then we are calling the CIFR dataset and it is loaded, and it is dividing into training data set. So training data set XY and the corresponding label. So we got 10 classes of images here. The shape of the training data set are printed here. So you can see the shape of the training data set is 50,000 images are there, and we are using 10,000 data as test data. So we are training the model using 50,000 images of 32 cross 32 size, and 3 is for 3 RBG layers. And you can see the shape of the training data set is 50,000 here. The shape of the training and testing sets are printed, and we can check the number here. So in the next line, in this particular, so you can see the number here. And the next line, when we move, now the process of data processing. So code normalize the pixel value of the images from the range of 0 to 225. Generally the colors are denoted by a number between 0 to 255, and when we divide these numbers using 250, it reduces to a number which is between 0 to 1, and as a result our data range is between 0 to 1. This step is essential for efficient training of neural network. So here you can see 10 classes are there, and here is a plot sample using index, and the label in the y training and the y test are initially in the 2D shape, and they are reshaped to 1D arrays using ytrain.reshape. So this dot reshape -1, this particular line is used for converting this particular array into a one-dimensional array. So here you can see this array is a two-dimensional array, and just the 5 data of training data set is a two-dimensional array is represented here, and using this code it is converted into a one-dimensional array. So this step is necessary for the categorical cross-entropy loss function. And then in the next phase we see some visualization of the data using the plot sample function. So the function plot sample is identifying the visual of a sample image and from the data set along with the corresponding class label. So here this function is takes the data set and its label and the index of the sample and you can see the visualization here. So here you can see the label and the image. So it is a frog image since it is only 220 to 32 pixel cross 32 pixel, and we are viewing it in a large scale, so the frog is not clear here. When we reduce the size, the frog is visible here. So okay, and here another number, when we change this particular number we can see different images. Now in the next step it is time to build your first neural network, which neural network is going to trained with some data, and it will capable to detect the category of image from the test data. So here we are dividing the training data set by 255 and also test data set by 255, so that these RBG values are reduced to a range between 0 to 1. Here in this particular code you can see the first neural network is built using the Keras sequential API. So it is coming from the Keras package sequential API, and it start with the flattened layers that convert the 32 cross 32 cross 3 input image into a flat vectors. So here it follows with two dense layers with 3000 and 1000 unit respectively, and the activation function use the rectified linear unit, which introduce non-linearity in this network. So dear friend, the model is so here it start with a flattened layer and then convert it into a flat vector, and then it follows with the two dense layers with 3000 and 1000 respectively, and the final dense layer has 10 units. Okay, and use these softmax activation. So here you can see it is using an activation function softmax activation function to produce probability of each class. In each dense layer you can see one activation function is used. The last layer is using the softmax. So here the model compiles with the stochastic gradient descent, which is called SGD optimizer, and the categorical cross-entropy loss function, and the accuracy is evaluated using a matrix. So when you run this particular code section, it will run 5 epochs and it will try to gain maximum accuracy. So here this model is trained on the training set X train and Y train for 5 epochs. It will take some time. For here you can see the accuracy level, the last accuracy level is showing 49% after running these 5 epochs. Okay, in the next step we will see that in the next step you can see that the accuracy of the training model is evaluated using X test and Y test using classification report from scikit-learn. So here the scikit-learn matrix, scikit-learn is used here for the accuracy of the training model. So here you can see the classification report here, some data from 1 to 9. The accuracy is 44% and weightage average is given. So now we need to build a convolutional neural network to train our image. So here in this particular section, try to understand this code here. The second neural network, CNN, so we are developing another neural network, is construct of image classification. It started with the conv2d. conv2d is a layer, or you can say is a filter with 32 filters or kernels of 3 cross 3, and followed by the ReLU activation function. So here you can see the kernel size is 3 cross 3, activation function is ReLU, and the input shape is 32 cross 32, 3 layers of colors. And we are also using another max pooling 2D layers of size 2 cross 2 and adding a downsample for the feature image. So here we can see the process is repeated with another conv layers and ReLU functions and another max pooling 2D, and then we have used a flatten function of 1D vector. So the feature map are then flattened to a 1D vector using flattened layer, and here we use the ReLU function and the softmax. So the ReLU function and the softmax is helping the classification. The two dense layer with 64 and 10 units respectively are added to the ReLU and softmax activation classification, and this model is compiled with Adam optimizer, and then this model is optimized with Adam optimizers and the and the cross-entropy loss, categorical cross-entropy loss, and the accuracy of the matrix is improved here. Here we see this particular function is, this particular neural network is trained with a normalized training, and for 10 epochs, so 10 epochs will maximize the accuracy. So later you can see the accuracy level is 79% here, and then here you can see that the accuracy of this neural network model is evaluated using the test set X test and Y test using the CNN evaluation, and the accuracy is around 70%. Okay, now it is time to do some prediction of the test data. So we are the model predicting Y prep and obtaining on the test set and the class with the highest probability of each sample is executed as a predictive class. So we are predicting for only 5 datas, and you can see the results here, and the classes for in the next step. So you can see the output. The code printed the predicted class of the first 5 sample. So there are actually 3 means. You can 3 means 0 means aeroplane, 1 means automobile, 2 bird, 3 means cat, 4 mean deer. So here the first 5 models are like 3 means this particular code. So here we are supplying one sample data, and you can see the image, and it is accurately plotting, it is accurately detecting the image. It is a frog image. So lastly, it prints the class name of the predicted class of the fifth sample and fifth sample in the test data, and again we also print the 7th sample and 13th sample. So a basic neural network and a convolutional neural network identified the image class, and now from this code you can see the steps. You can see the steps here, and from this code you will get some question and answer. Like, let me show you the question and answer here. Once again, I'm showing you the code here. This part is for importing the necessary package. This part is for importing the data, and these are just for checking the shape and checking the data. Here you are defining the types or classes, and then you are using some functions here. We have discussed about this. Now let me show you some question here. Okay, so what was the purpose of normalizing the pixel value of the image in the CFR dataset? Why the flattened layer is used in the first neural network? So the flattened layer is used to convert the 3-dimensional inputs to 1-dimensional vector. That was the reason. Next question is, what activation function is used in the dense layer of the first neural network? So we use ReLU function, rectified linear unit activation function is used in the dense layer of ANN, and ReLU is popular activation function that introduce non-linearity and help in overcoming the visual gradient problem, and it replaces all the negative value with 0 and keeping the positive value unchanged. And how the loss function defined for training the first neural network? The loss functions are used for training the Loss functions are used for training the ANN for the purpose of categorical cross-entropy. The loss function is suitable for multi-layer classification problem where each input sample belongs exactly to one class, and this variant is used since the class label is provided as integrated integers rather than one hot encoded vector. Let's move to our next slide. Why the neural network architecture prefer for image classification tasks? So why it is prefer? Because neural network prefer for image classification due to some ability of automatically learning hierarchical feature from the image. The CNN are used for convolutional layers and that detect local pattern and feature of an image, followed by pooling layers and downsample and reduce the dimensions. What is the purpose of using max pooling 2D layers in the second neural network? So in the second neural network, we use max pooling 2D layers. For this operation, reduce the spatial dimension of the feature map while retaining important information. Max pooling help in making the model more robust to translation and reduce the number of parameters, which aids the preventing overfitting. Our next question is why the Adam optimizer use for training the second neural network. So Adam optimizer is a popular adaptive training, and it is used for training a neural network, convolutional neural network, because it combines the benefit of both adaptive learning rate and monument based optimization technique. Adam adapts the learning rate based on the moving advantage of past sequence gradient and make it well suited for training deep neural network and achieve faster convergence. Our next question is how is the accuracy of the second neural network evaluated in the test dataset? So the accuracy of second CNN of the test dataset is evaluated using the CNN.evaluate x_test y_test function, and this function import the loss and the accuracy metrics on the test data and return the test accuracy as a result. Let's move to our next slide. And what is the purpose of classification report for scikit-learn? What is the purpose of classification reporting from scikit-learn? The classification report is a utility function from scikit-learn used to generate comprehensive classification performance report, and this provide precisions, recall, F1 scores, and report support each classes in the classification problem. And this report help in understanding the model performance on the individual class and overall accuracy. So you can see the classification report of the classification function here, and why this classification report is from the scikit-learn. We understood that it generate a comprehensive classification performance report. You can understand the model performance from that report. Our next question is how does the second neural network outperform the first neural network for image classification? That is a very important question, and we use this particular data set. So the CNN architecture in CNN outperform the base network of image classification due to the following reason. CNN can automatically learn and detect hierarchical feature from images using convolutional and pooling layers. CNN are specially designed for image related tasks, leverage the spatial relationship in the data. Pooling layers in CNN reduce spatial dimension and help in making the model more robust. CNN have fewer parameters compared to fully connected layers, which help prevent overfitting. The ReLU activation function in the CNN introduce non-linearity, enabling the network to learn complex patterns more efficiently. Dear friend, let's see some. Here we are just training our dataset using 10 epochs. You can see it will take some time. In the meantime, let's see some question and answer relevant to this topic. So what is epoch? It is a very important question. What is epoch? Let's see. So in the context of training a machine learning model, an epoch referred to single pass of the entire training data set and through the neural network. During each epoch, the model iterate over the entire data set, update the parameters like weight and bias, and you can see the epochs are running right now. So entire data set is running through your network. So during each epoch, model iterate over the entire data set, update the parameters of weight and bias, and it calculate the forward and backward propagations step. Like forward propagation means during the forward propagation, the model takes the input data and pass it through the layers of the neural network and calculate the output or prediction for each sample. There is loss calculation. So loss calculations are like loss calculations during the forward propagation, the model compare the prediction to the actual target level from the training data set, and the difference between the predictions and the true levels is measured during the loss function, and which quantify the error of the model's prediction. There is backward propagation. Backward propagation means once the loss is computed, the model performs backward propagation. It calculates the gradient of the loss with respect to model's parameters using the chain rule of calculus, and the gradient to represent the direct and magnitudes of the changes required to maximize the loss. Then you have the parameters update with the gradient compute during the backward propagation. The model update the parameters during the optimization algorithms such as gradient descent and one of its variant, and the goal is to adjust the weight and the bias in a way that reduce the loss and thereby improve the model's performance. There is iterative through the entire dataset. The above steps are repeated for each sample in the training dataset, and after doing this you can see that your dataset, your particular model is performing better. So when one dataset is completely trained through the model, then again we train the model using the same dataset. That's why multiple epochs are there. The number of epochs is a hyperparameter that the data scientist or the developer set before training the model, and it is important to find the balance in the particular. So it is when too few epochs are used, and then you can face some underfitting situation, and when too many epochs are used, you will see some overfitting situation. And so you have to use at least 10 or 5 epochs for training your dataset. So dear friend, I hope here you can see the steps we use in this particular project. Here is a summary. First we load the data and then do the exploration. So you can see for loading we have used this sample code, here we are importing the functions, and then we check the dimension or shape of the function, shape of the data. So these are done in this area. Then we define the classes here as an array, and then we train the, this is data preparation stage. Here we divided all the pixel, we changed the pixel value, just its range is changed from 0 to 255 to 0 to 1 by dividing 255. Okay, and then we use some plot sample function. So where we use some plot sample function here, and plot sample function, after doing the plot sample function, you can see the results here. After doing this, using this plot sample function, you can display the image and the label. And after that plot sample function, we build our first neural network, ANN, and use the activation function ReLU. So here, this is the first neural network is using. We use two dense layer, actually three dense layer and one flattened layer of 3 cross 3, and two activation function and one activation function as softmax. So you can see this here. As a result, we run 5 epochs after that for training our model, first CNN, first neural network model, and then we use another stochastic gradient function as an optimizer, and the code is here. For categorization, we have discussed this, why the stochastic function is used. And then the model is then trained with the training set. Where this is done, you can see here, you can see the accuracy around 59%. In the next step, we create a category accuracy training model is evaluated using the classification report. So how the classification report is used, here we have imported the particular function here, classification report, and it is producing this classification report here. Then we are building our second convolutional neural network using several layers, one flattened layer, one dense layer, two dense layer, and we use the conv and max pooling 2D 2 times here. So we start with conv layers with 32 filter kernel of size 3 cross 3 and the ReLU activation function, and again we run 10 epoch using this second neural network. And now our model is more trained for testing the data. So you can see we train 10 epochs. All the images are passing through this network, and the accuracy level is 79% is achieved. And now we are testing our test data contain around 313 images, and here it is showing the first 5 images category here. So the step is, after that the model predict yprep and obtain the test data, and lastly it print the class name of the predicted class of the segment sample in the data. So you can check 7 sample of the data. So this is how we completed the classification, image classification using neural network. I hope this video is helpful for you, and the sample code is here. In Google Colab, we have used only these steps, and I will share this as a link on the description below. Thank you so much for listening. See you guys in the next episode.